For assignment number 7, solve for the value of Vx under DC conditions and for the 4 configurations. So if a 10 ohm resistor is connected between terminals X and Y, next is if a 1 Henry inductor is connected between terminals X and Y, third is if a 1 farad capacitor is connected, and last is when a 4 Henry inductor is in parallel with a 1 ohm resistor. So under DC conditions, inductors are equivalent to a short circuit and all capacitors are equivalent to an open circuit. So we can simplify our circuit before proceed solving. We have lead source, then the 5 Henry inductor is equivalent to a short. We have X and Y. And we have open circuit. And we have a short circuit. We have right here a short circuit and connected to an open circuit. So this is Vx, 12 ohms, 15 ohms, 5 amperes, 20 ohms, 30 ohms, and then 1 volt. So furthermore, we can simplify the circuit by using source transformation here. So using source transformation, our circuit becomes, we have a current source in parallel with a resistor. Then we have terminals X and Y series with a resistor. And we have current source, then 2 series resistors. So this is 1 over 20 is 20, 20, 5, then we have 15, and then 12. Now for the first case, if a 10 ohm resistor is connected between X and Y, we have there's a 10 ohm resistor connected here. Now solving for I using CDT, and solve for I is equivalent to 1 over 27 over 1 over 27 plus 1 over 30 plus 1 over 20 times, we have 1 over 20 minus 5. 1 over 20 minus 5. So I is equivalent to negative 99 over 65 years. So our Vx equal to 12I, or is equivalent to negative 18.277 volts. Next case, if a 1 Henry inductor is connected between terminals X and Y. So using this circuit, we have A, we have B. So if a 1 Henry inductor is connected, so at DC condition, a inductor is just equivalent to a short circuit. So using CDT, can solve for I. So I is now equivalent to 1 over 27 over 1 over 27 plus, in this case, it is 1 over 20 plus 1 over 20 times 1 over 20 minus 5. So we have negative 24 over 24 amperes. Now solving for Vx equivalent to 12I, our Vx is equivalent to negative 16.054 volts. Now for the third case, if a 1 farad capacitor connected between X and Y, using the same circuit, so a capacitor at DC conditions is equivalent to a open circuit. Solving for I using again CDT, we have 1 over 27 over 1 over 27 plus 1 over 20, because this 20 ohm resistor is now disconnected, times 1 over 20 minus 5. We have negative 99 over 47 amperes. Now solving for Vx is 12I. We have negative 25.277 volts. Now last case, if we have a 4 Henry inductor in parallel with a 1 ohm resistor. So using the same circuit, we have a short circuit parallel with a 1 ohm resistor. So this circuit right here is just equivalent to circuit right here. Top. So they are just equivalent. So I is just negative 94 over 74 amperes, and Vx is just equivalent to negative 16.054 volts. Now for assignment number 2, it is assumed that all the sources in this circuit shown have been connected and operating for a very long time. Use the superposition principle to find Vc of t and Vl of t. So first, let's consider the 20 milliampere current source acting alone. So have 20 milliampere thing alone. So we have current source is 0. This is open, and this 9 volt source is shorted, and this current source is open. So we have milliamperes, 20 ohms. We have VC1, and we have VL1. So VL1 just 0, and VCO1 is equivalent to negative 20 milli times 20 is equivalent to negative 0.4 volt. Next case is when the 30 milliampere source is acting alone. 30 milliampere acting alone. We have ohms and then 30 milliampere. So VL2 is equivalent to 0 volts, and VC2 equivalent to 30 milli, this current right here, times 20 ohms. We have 0.6 volt. Now for the third case, we have the 9 volt source acting alone. We have so VL3 is equivalent to 0 volts, and VC3 is just equivalent to 9 volts. Lastly, the 40 cosine 10 to the 3t milliampere acting alone. We have since our source is not DC, but is changing through time, the capacitor is not open and the inductor is not shorted. Now since this is shorted right here, the current of this current source is just flowing through this mesh. So meaning our VC of 4 is equivalent to 0, and then our VL of 4 is equivalent to, so remember the equation for a voltage across an inductor. So we have, following the passive sign convention, we have negative 60 milli times the derivative of this current, 40 cosine of 10 to the power 3 t. This is milli. Solving for this derivative, we have the value of 2.4 sine 10 to the power 3 t volts. So finally, our VC of t equivalent to VC of 1 plus VC2 plus VC of 3 plus VC4 equivalent to 9.2 volts. Our VL of t is equivalent to VL1 plus PL2 plus PL3 plus PL4 equal to 2.4 sine 10 to the power 3